And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. And we've got tons of stuff to cover today. Let's get to it. First, looking at the sun here in 304 angstroms. We brought it back 2 days to show you the moment of the coronal mass ejection that happened right there. You can see it in the upper right in the northwest corner there. Since then, there's been some calibration happening on the SDO. We've got a bunch of other views for you here. And the coronal mass ejection is probably not finished. Let's head out to Lagrange point 5 and have a view of the sun from this angle at stereo A. So a little bit of fireworks kicking off on the 6th around 11 o'clock Universal Time. That non-Earth facing coronal mass ejection. Don't be surprised to see more because there's still a lot of plasma suspended out there, you can see in this area right here. So there could be more ejecta coming. We'll be keeping an eye on it. Hell, when I say eye on, the pun's intentional. Now let's head back to Lagrange point 1 here at the Discover spacecraft. And there you can see that coronal mass ejection from the LASCO C2 coronagraph. Let that play through a second time. It was featured on yesterday's Daily Space Weather video thumbnail. And here's the same view zoomed out from the LASCO C3 coronagraph. And you can see that's expected to miss the Earth well off to the west. I just brought up an image here in 174 angstroms from the SOHO as well. And let's look at some custom HelioViewer stuff. Actually, we have a sunspot that's just kicking off. And just bear with me a moment, folks. And here actually is that sunspot. Let's see. Kind of coming out of nowhere there. And it's already a beta class, so the chance for X-ray flaring has gone up a little bit now. We did see 2 opposite polarity umbrae there while I did show prep, so this could suddenly go away as fast as it arrived. But a little bit of activity kicking off there. Radio flux is still at 71 solar flux units, and the KP index is still at 1. There is a weak coronal hole wind stream striking right now. We don't see any major solar flares or proton strikes. Real-time solar wind stats are as follows. Solar wind density ramped way down from yesterday to about 5.4 protons per cubic centimeter. Some missing data there in the recent portion. Current solar wind speed coming off of its highs, which are around 412, down to around 400 kilometers a second here. Like I said, it's a pretty weak, slow coronal hole wind stream there. And it looks like it's already ramping down if I had to guess. Here's the magnetosphere. And we're going to be talking magnetohydrodynamics in a minute, dynamos and so on in today's Cosmology segment. After this, we're going to look at the ground magnetic perturbations. That's 4 hours of data on the magnetosphere. And let me just check the stream life. And we look like we are just fine here at the Smash News Network. This is SNN, the least busted name in news. Here are ground magnetic perturbations. Delta B changes in the Earth's B field. We view it daily since we're living through a polar excursion. Anyway, there's 4 hours of data. Let me bring that back to where it was before it refreshed, as we don't want the video to be too long. Lots of more stuff to cover. And there's the GOES magnetometer information. And you typically do see some sawtooth looking readings here when you see coronal hole wind streams or coronal mass ejections. No real surprises there. We are solidly in the South Pole current sheet, although we could get in the North Pole current sheet as a result of that sunspot. So this could suddenly change. You can see this little void area opening up here, possibly pulling the north polarity portion of the current sheet toward the Earth's potential field force lines, which are shown there in orange. Here's a line of sight field plot. That was the top view ecliptic plane. This is the line of sight showing you the B field. In blue, no major changes there yet. And we see some changes happening with respect to the south solar polar region of the corona. This is a magnetic field force plot of the corona itself. And some of those are looking a little bit anomalous there. I'm not so sure that that's good data. Equatorial coronal holes connecting with the south solar polar coronal holes. Not so sure on that one. Let's continue on, as it's time for another episode here at the Smash News Network for the Smash Lights. It's the segment where we talk about whatever we want. And today we're going to start talking about the scary, spooky coronavirus. And we're going to go to cdc.gov. Please leave a comment if you'd like a national mask mandate. Please leave a comment if you find the CDC, if you find coronavirus to be now statistically irrelevant. Please follow me on Twitter if you don't. It's twitter.com/smashamash. Approaching 1,900 tweets. We've got this great carbon dioxide versus temperature graph pinned on the page right now. Did you hear what Magic Johnson was saying about the debates last night? Oh, man. Also, please follow Dr. Simone Gold, who's always putting up interesting stats, like the life expectancy in the U.S. is 78.7%. The chance of surviving COVID-19 over 70 is 94.6%. Are you scared and spooked? Oh, my God. Let's talk about... No. Nice try. Gaff machine. Dan Quayle. By the way, we do stream live to Twitch most days thanks to our followers over there. It's twitch.tv/smashamash if you want to see the content when it comes out. Please take a moment to press like and subscribe on YouTube, as the Smash News Network cannot continue to function without your likes. You must leave a comment or we may go out of business in 5 seconds. So please leave a comment. Press pause. We'll be here when you get back. We're also on BitChute. There's exclusive content on all our different sites. And you can find them all at smashamash.org, which will redirect you to smashamash.com. Let's do some cosmology. Now, we've never seen a star form or a star die. We've seen stars stop emitting light, and we've seen stars begin emitting light. But just the idea that we know what a stellar nursery is just ridiculous. We've never seen a star form. We've never seen a star die. We've seen supernovae. Typically, the shells around supernovae typically always contain a star right in the center of them for some strange reason. But it is interesting that stars and planets would form at the same time, right? I guess so. Anyway, there's an article on phys.org about it. And depending on what your theories of how planetary formation occurs, well, this may be interesting to you. I'm not that interested in exoplanets. I'm more interested in heliophysics, as exoplanets are not quite as important as our understanding of how the sun works. So the physics of that are much more important, and that's why I actually find cosmology more important from a more distant perspective than from planetary cosmology, although there are some interesting topics, and we're going to get to one. Let's talk about metallicity. In the realm of astronomy, anything more massive on the periodic chart than helium is considered a metal, and this all has to do with Generation 1 and Generation 2 star theories. And without getting deep into the weeds on how stars seem to produce heavier elements, Manganese seems to have something to do with type 1a supernovae. Now, interesting here is the article actually goes on to state that type 1 supernovae are not the kind that destroy the star, but they are the standard candles to measure the expansion of the universe. So, anyway, it's not known, it's believed in classical astronomy that massive stars within a certain perfect sweet spot of the mass range create shells of heavier elements inside them and then explode. Some of us believe that happens in the atmospheres as opposed to within the stars, as we see more and more evidence of fusion happening in atmospheres, not within stars. Also, why is there so much hydrogen? Why is there so much hydrogen, folks? Why is there so much hydrogen? Anyway, these type 1a supernovae are believed to involve a white dwarf interacting with another star, and that's where all of the heavy elements come from because they're coming out of one star and so on. If you want to read that, it's also on phys.org in the Astronomy and Space section. Let's talk about the most interesting article. Was the moon magnetized by impact plasmas? Yes. Yes. Was it magnetized by impact plasmas? And how are magnetospheres generated? So these are kind of important questions when it comes to geology and all of astronomy, as the Dynamo Model, which is actually linked in this article. If you read the article here, and by the way, Be Stoic and some of our other viewers should be very interested in this, as this has to do with impacts and how they affect a body like the moon, which does not have a coherent magnetosphere of its own. In any case, the Dynamo Model is, see this cutaway of the Earth here. This is this cutaway of the Earth here. This is the mode by which the Earth's dynamo is believed to be generated by most mainstream folks. You've got this inner core and this outer core, both made of liquid iron, and the liquid iron convects back and forth through the outer core, and that's how it's able to generate the magnetic field. Apparently these people weren't aware of the Curie temperature, which means when you liquefy iron, it loses its magnetic properties because, well, a plasma can't generate a stable magnetic field. What are the pressures down there at the inner and outer cores? Well, again, without getting deep into the weeds, I suggest you read the article about the lunar dynamo and the lunar crust, as there are magnetic anomalies that are measured from space on the surface of the moon, and it's not understood how those formed. Did the moon previously have a magnetosphere, which has now been reduced to a shell on the surface? Or was the magnetosphere induced by incoming plasma, whether it's from a meteor strike or from a coronal mass ejection? Who knows? But anyway, perhaps read the article. Again, it's got the link to this MIT news article here about the explained dynamo theory, and it's more of a hypothesis if you ask me. By the way, this does not explain why there's so much hydrogen in deep boreholes. Incidentally, the deepest borehole is nowhere near the mantle. It's not even through the crust. So again, perhaps read those articles. We don't want to spend too much time on it. Let's talk about the October contest. It's more like a sweepstakes. If you want to sign up, if you'd like a free shirt, head to smashamash.com/forum. And in all of the forums, we've got the October contest announced, pinned. All you got to do, make sure you have a login, otherwise you won't be able to post. And post the words, "Sign me up," and we will enter you into the quantum-generated drawing, taking place toward the end of the month. We will have a winner selected by Halloween, and we finally got the design completed. This is what it's going to look like. You can't buy the shirt yet. You'll be able to buy the shirt perhaps after the contest, certainly. It's only going to be available in choice colors, all in the blue spectrum. Why? Because Deneb's a blue star, the celestial pole star, and it features Deneb along with an inset of its radio jets, otherwise known as Cygnus X3. The high-mass X-ray binary system is one of the world's only known cosmic ray point sources. Here's a high res of the design, and it's very high res. It looks totally sweet. And there's what the inset looks like, featuring the radio jets oriented toward and away from Earth. And that's a composite, including Chandra X-ray imagery, which shows you the little friend believed to be a neutron star, quark star, black hole, blazar, quasar, who knows. But a very, very massive object orbiting at a very, very high speed, a very, very massive, very, very large Wolf-Rayet blue supergiant, which would be the size of Mars's orbit. And here ends today's Smash Lights, where we talk about whatever we want, and then we move on very quickly, because there's still lots of stuff to cover at the Smash News Network. We've come out of the electron storm mode, and we're in a more normal level of electron flux. Charging hazards have diminished. You should see better communications, GPS performance, etc. Here is the relativistic electron forecast, and it's pretty flatlined. I put up a 7-day graph once again because we briefly got into warning territory yesterday, only for a brief period of time, having come off about a week-long serious electron storm. Although it looked like everything fared pretty well. Here's the current situation in terms of a visualization of the electronification of the full range of the atmosphere, all the way from the thermosphere down to your handset, is what this one is attempting to depict. Here's just one slice, just the ionosphere layer, and it's looking a little anomalous here. And we'll let this play through as we're now showing the entire day as opposed to only 6 hours. And this data is courtesy of Australian Government Bureau of Meteorology. Pardon my posture, I tend to slouch. Pretty heavily charged up here on the sun side and pretty heavily discharged on the non-sun side during parts of that cycle. That cycle being 1 day. There's the current image looking fairly normal there. A little bit charged up on the southern side, and hey, it is spring down there. Next, looking at in-the-sky.org. Today's featured object is Deneb. Where will you be when Deneb sets? By the way, if you're up before dawn, you may see Venus also, my favorite planet. Have you noticed how my scrying with Smash forecast has come true? Venus and Mars have switched places. Now everybody wants to go to Venus instead of Mars. I certainly do. It's a shorter trip, folks. You don't want to spend 10 months each way going to Mars and then die of cosmic ray flux. Here's where stuff is in the solar system. There's where things will be in a week. As Mercury swings around for another pass, we approach a new moon. We've had a 6.7 magnitude quake near Papua New Guinea, and we don't see any tsunami warnings, advisories, watches, or threats. That's good news. And it came in as I did show prep, folks. Yes. Is it divine providence or just luck? We're still seeing a lack of earthquakes around the world. Here's a very shallow quake at a depth of negative 1,100 meters. Yes. Yes. And do you think it's under Mauna Loa? It certainly is. There's the location of that quake. Happening 1.1 kilometers above sea level. By the way, that Papua New Guinea quake was at about 75 kilometers depth. And it just happened. There's a deep quake at Fiji. It's at over 600 kilometers depth. And by the way, nobody's drilled to 600 kilometers depth. Please leave a comment if you think there's a lot of hydrogen down there. Here's a 4.8 in the Band-Aid Sea, west of where that 6.7 happened a few hours later. Many hours later. About 8. And let's see, what else do we have here? Here's a deep quake at Chile. Again, we are seeing a shortage. Oh, the depth has been changed. The depth is actually 103.5 kilometers, so that could be a foreshock, as we are seeing a drought of 7, 8, and 9 magnitude earthquakes. So if you're in these regions, please have an earthquake plan. Try to be an asset, not a liability, if buildings start to fall. And keep in mind that earthquake droughts end in earthquakes. And it's been updated. Nothing happened, folks. Next, looking at volcanoes of the past 24. Today on October 8th, Etna's erupting again. Sporadic ash emissions there. Kluchevskoy, one of the more significant volcanoes of the past year or so, exploding, producing an 18,000-foot ash plume. Suwanosejima exploded as well, 5,000-foot ash plume there. Kadivar, 6,000-foot ash plume there. Semaru exploding, flight level 130, 13,000 feet. Oh my God, was it COVID? No, I don't think so. Popocatépetl exploding, flight level 210, 21,000 feet. Sangay exploding, flight level 200, 20,000 feet. Revenador exploding, 15,000-foot ash plume there, and we're unable to detect a volcanic ash plume at Sabancaya. And let me be the first guy to tell you here at the Smash News Network not to attempt to pole vault the caldera, as that could be unhealthful. And then you won't be able to press like and subscribe on YouTube and share on your social media. Here's the weather.gov map, and we see insult to injury added to the northern Gulf Coast. Sorry about that, Louisiana. It's looking bad. And here is the Tropical Tidbits forecast, and you can see massive rainfall forecasted here, 12 inches. That map there is the GFS forecast through Saturday at 1800 Universal Time. Looking unfortunate. Shout out to our African and European viewers. There are your water vapor maps. Shout out to those from the most easterly portion of the planet. There are your water vapor maps. Here are the water vapor maps of the Americas. Here are the jet streams of the eastern world. Here are the jet streams of the western world. We do see a small jet stream input there associated with that hurricane. That is not a good sign. Although it is not rotating clockwise. If you see an anticyclonic action at the top of a hurricane at the jet stream level, not good. Here are the surface winds, if you're wondering. Next, looking at pressure cells. We're going to bring this up to tomorrow at 12 noon. There's where we expect them to be at 12 noon tomorrow. Just about making landfall will be that low. Expected to be at about 29.2 millibars. I think it's millibars. Here's a lightning situation. I like to use